Algebra 2, we're in lesson 32 today, and we're going to be talking through congruent theorem for square roots is our number one thing, and number two, we're going to look at congruency and congruent triangles. So we're going to start right in with the problem of 32.1, which says simplify this problem, and we have 3 over 7 as far as a fraction in a square root. Now, that's a problem because we can't have a square root be a fraction. It's kind of like a square root being a decimal. It can cause a decimal, but we can't start it with a decimal. So what we're going to do is, since this 3 and the 7 are both in root form, to get 7 out of the actual root, that is, out of this context, we're going to multiply the bottom and the top by a square root of 7. So what we're left with down here, 7 times the square root of 7, which again, it's within the square root, so it's like saying square root of 7 times square root of 7 equals 7. We bumped it out of the root, and then this 3 and 7 still remain. So the numerator stays in the square root, but the denominator, because we're multiplying by itself, takes a different form. So the only way to get this top to get out of a look like this would be to multiply it by the square root of 3, because the square root of 3 times the square root of 3 is equal to 3. But that's not our play. That's not how we're achieving these questions. Let's go to another one that may be just a little bit harder. In 32.2 on page 144, we have the square root of 2 over 5 plus the square root of 5 over 2. Okay, we have to take each one of these individually. So let's do this one first. Okay, let's rewrite down here so that we can mess with it. Again, we said to get 5 out of that root, we have to multiply both the top and the bottom by the square root of 5. So that's going to equal now the square root of 5's on the bottom. Okay, we just took this out, and then 2 times 5 is 10. Now let's deal with this one. All right, let's rewrite. And we said that the square root of, forgot the plus, 5 over 2. So we're going to multiply by the square root of 2 over the square root of 2. That means we are going to equal 2 over the square root of 10. So here we have the square root of 10 on top, and now you're going to notice something that's a little bit unique. I'll get a different color here. All right, you're going to notice a 5 and a 2, and just like common denominators, we can't add this yet because we need a common denominator. So how are we gonna multiply or get a common denominator? You know the common denominator is going to be 10. So here's what we're going to do. We're going to multiply both the top and the bottom by the opposites of each fraction. Okay? So what we're going to have left, okay, out of this one right here, we're going to have 2, the square root of 10, over 10, because 2 times 5 is 10, plus 5 to the square root of 10 over 10. Now both of these denominators match up, so what we can do is we can add these two numbers. So we have 7 to the square root of 10 over 10. And that is our final answer. Okay? Let's do one more. Okay, this time 32.3, we have 3 to the square root of 7 over 3 minus 5 to the square root of 7 over 3. So we see the reciprocal. All right, first things first, we have to multiply the opposites, okay? We can rationalize this. So if this is the case, what this really looks like is 3 to the square root of 3 over the square root of 7. And then this one looks like 5 to the square root of 7 over the square root of 3. And again, it's kind of like turning a square root into a improper fraction, and this is the result of that. So when we do this, now we can again multiply, oops, that'll be a 7, by the square root of 7 on both sides. So we have 3. 7 times 3 is square root of 21 over, and then 7 times 7 is 7 out of the root. Now that's gone, right? Minus, and then we're going to do the same thing. We're going to square root of 3, square root of 3. So we have 5, the square root of 21 over 3. Okay, here's the problem. We got a denominator that doesn't work. So what we're going to do is we're going to multiply each side by 3. This side is going to be multiplied by 7. So the denominators are going to equal 7 times 3, which is 21. Now the numerators. Well, what's 3 times 3? It's 9 to the square root of 21. 3 times 3 is 9 to the square root of 21. That's what this one is. And then 7 times 5, so minus 7 times 5, which is 35 to the square root of 21. Well, what's 9 minus 35? Well, you have a negative 26 to the square root of 21 over 21. There is our answer. Okay, so these are pretty simple. You just have to rationalize those square roots. Okay, let's go to the next idea, congruency. Okay, if we have a line here, we call this A, we call this B. We have a line here and here, and we call this D and C. And they're exactly the same. They are said to be congruent and equal. All right. So again, if we have an angle of 37 degrees and another angle of 37 degrees, and we call this angle A and call this angle B, they are congruent and similar. So we could do this several different ways. We could say A is equal to and congruent to B, and B is congruent and equal to A. Not hard. Okay, in your textbook, we're going to get some triangles. And the triangles are going to have different values. Okay, and you'll also see different tick marks that are given here. Call this value 12, this is 10, and then this is going to be 14. And then you have another triangle that's tipped over, but basically it's the same thing. And you're going to notice here that there are going to be similar angle marks, and then there's going to be some similar numerical information. So both of these are the same triangle. They're congruent, okay? And we would say that they're equal and congruent to each other, okay? That's not hard. All that happened is we tipped from this one, we rotated, okay, this side. All right, so it's just rotation. Okay, so it's really nothing different than that. If we wanted to say something was mirrored, okay, same thing. If this is a grid and we've got a right triangle over here, and then we put the right triangle on this side, mirrored, okay? But they are corresponding and they are congruent and equal to each other. All right, that's an easy concept. We're going to take this to an example where congruent triangles are going to mean something. And then there's an acrostic, which basically is CPCTC. What does that mean? And this is geometry, so pay attention because this is a proof. It means corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Corresponding parts. What do you mean, corresponding parts? Well, it means that 10 and the 12 and the 14 were the same as the 10, the 12, and the 14. It just was flipped. The triangle was flipped. So to prove corresponding parts of congruent triangles are congruent, we can do that with some algebra. Okay? So here you're going to have a triangle, and it's going to give you an expression. Instead of a number, it's going to give you an expression, which is 4x minus 1. This value is 6, and then this expression is 6x plus 2. And then there's a similar triangle, not rotated, similar triangle, and it's going to have similar expressions. So notice these two are the same. We're going to put p here, and then we're going to say this one is 12x minus 4. All right. How do we figure these out? What do we do with them? Okay, we know that because of the orientation of 6 and 6 that they're orientated same. They're equal to and congruent to. So this equals this, right? 6x plus 2 equals 12x minus 4. Can we solve for x? Well, we should be able to. Let's add 4 to both sides. Get rid of this. And then let's subtract this 6x and subtract 6x. So we eliminate that. So here we have 6 equals 6x. We divide by 6. X equals 1. Okay, so when we put the number 1 into this equation, so 6 times x, which is 1, plus 2, 6 times 1 is 6 plus 2, we know that that value is 8. Does it work over here? Let's see. We know that x is 1, so 12 times 1 minus 4. Well, 12 minus 4 is 8. So even though these look different, it's the exact same number and result. So we get 8. And then we can solve for other things. Okay, if we know what x is, if x is 1, 4 times 1 minus 1 is 3. So we know what p is. P is 3. This is 3. 3, 6, 8. 3, 6, 8. We have solved these problems. Okay, so hopefully this will go well in your lesson. Let's do question number 7 in your lesson. Actually, you know what? I think I'm going to let you guys ask me questions if you don't understand it, because I think it's an easy concept for this one. Okay? All right, there's your lesson, lesson 32.